All right, let's do this problem. This is a problem that, yes, it is a test question. And you will see one like this. This is the second type question. Basically, when you're given a mean and a standard deviation. So go ahead and write that one down. It says assume a random variable is normally distributed with a mean of 50 and a standard deviation of 7. So when you see that mean of 50 and standard deviation of 7, the first thing you're going to do is draw what? Draw a curve. And go ahead and fill out the curve. And go ahead and put your z-scores and put your empirical rule percentages. So go ahead and be doing that. So everybody should be drawing all that out on your notebook paper. So go ahead and do that. Come on, let's go. Get your notebooks out. That's what you're supposed to be doing. Now, you may not be able to do the question, but you all should be able to do the picture or the curve. I call it a picture because it's a whole lot easier to say than natural distribution curve. So I just say picture. And yes, I have questions from you. I meant as a class. Usually I get like 10 questions, but this class is just exceptional. I don't get from this class, so I don't get questions from this class as a whole. So either one of three things. Either one, you are gifted and talented. 3, 2, very good teacher. Or 3, some of y'all haven't done the homework. So we'll just leave it at those 3 and say, hopefully it's probably the first 2, right? So let's pull up the whiteboard. So basically it's going to look like this. And we have a 50, 57, and a 70, and a 60, what, 4? Yeah, it's one further. So 71. And then a 43, and then 43 minus what, 60, or whatever, 36, and then 29. So we know that we got 0.15, 2.35, 13.5, 34, 13.5, 2.35 and 0.15. 0, 1, 2, 3, -1, -2. Now remember, you're going to have to draw those pretty much every single time, unless you're one of those water walkers or one of those people that know it all. Okay? So you might want to do what I said and copy some over and do the, the copying thing. It might help you out. So, this says between 52 and what? 68. So I take my blue marker and I'm going to do 52. 52 is going to be right in here, right? And that's going to be that area. Now remember, if you don't have a calculator, you're going to have to take the smaller away from the what? The larger. So that's your smaller. And then 68 is going to be in here somewhere. Now, let's talk about, what do you think? I think the 52 is maybe what, 52%? Let's just say it's 52%. Now that's a coincidence that it comes out like that. And what is the 68? 68 is more, it's not 52%, it's not 68%, you can tell, because this is what, 81 or 84%? What is this? This is 84, and this is what? 84, 97, 97, so that's about, I'm going to just say 98. So 98%, that'd be 4. Take this, that'd be a 4, I'm sorry, a 6, and 9, that's 46. So I'm thinking around 45, 46, what? Percent or 0.46, yes sir.
Why did you put the blue going there?
Why did I put what?
Why did you shade the blue going that way? Where it going? Because it's
Which way do we read?
Left to right, but
so there it is on the left.
I just
On the graph, on the table, what did I tell you about the table? The table always gives you the area to the what? To the left. Everybody got it? So that's why I'm putting all the areas on the left. You understand? Okay, so now I've got an approximate because I want to always check my approximate. Here is the area I'm trying to find. So if you don't have a calculator, you're going to have to change these into z-scores. So let's change them into z-scores. So the first one is going to be 52 minus 50 over what? 7? Okay, so that's going to be 52, so that's going to be 2 over 7, which is like 0.3. Okay, and then we're going to do 64 minus 50 over 7, which is equal to what? 2. So if you have your, and we're going to pull up the table right now. Somebody give me, what is 2 divided by 7? Point what on your calculator? What is it?
0.2857.
0.285 be 29. All right, so let's pull up the calculator. I mean, not the calculator. Let's pull up the table. Damn Russians. I'm sorry, Ukrainians. All right, there is the table, and I'm just pulling it up. I can't make it larger or anything, so you're just going to have to squint your eyes. And I'm looking for 2, and 2 is 0.9772. So let's write down 0.9772. 0.9772, and then we're going to subtract. Let's find 0.29. 0.2, and we know that 9 is all the way over here, and of course I can't see it. One day. 2050. .29 is going to be 0.6141. Somebody check that for me. 0.6141. That's a little bit more than I thought it was. And when you subtract the two, well, 97 cent minus 60 cent is 37 cent. So evidently I was a little bit misrepresentative of the blue. I thought it was smaller than it was. They said it was 52. So I said it was 52. They said it was 61. So that's why I wanted to make sure I read that right. 0.6141. So if you subtract those, somebody give me 4 digits. What is it?
0.3631.
0.3631. 36%. Write that down. Now let's do your calculator. Okay, which calculator function do we use? I'm sorry, I heard boo, 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 boo. Normal what? CDF. So pull up normal CDF. Let me pull up calculator. One day. Like I said, maybe
Click on that.
2015, 2050. So second bars. And normal CDF. The lower limit, what did we get? Point what? Or I'm sorry, what's my lower limit? 52? And see, I'm gonna do the 0.29, sorry. 0.29. And then upper is, what was the upper? 2?
Yeah.
And paste.
Whatever you do your green.
And enter. 0.3631, is that what we got? Okay, so now let's do it the other way. Second bars, normal CDF, and this time I'm going to put in 52, and I'm going to type in, what was the other one, 60, what, 4?
68.
Was it 68? Because I got 64 right here. That's why I'm off. I didn't do the right. I did 64. I'm sorry. That's why I'm off. 68, and now I changed my mean to what? 50, and my standard deviation to what? 7. And if you have one of these calculators, a newer calculator, it should do everything for you. That's what it's supposed to be. I did the wrong. 0.3824 is supposed to be. I did 64 over here. Sorry. Let me pull up my handy dandy question again. Well, right now I'm still trying to work with. So much easier in another classroom when everything's set up. Okay, I put 64 right here, I guess because my eyes just caught that 64. I don't know why I did that. So 68 minus 50 is what? What does it come out to be? 2 point what?
57.
2.57. So that was my problem. I knew there was something wrong when, I know it's not 46%, but it's 38%, which is a little bit closer. So my bad on that one. That's supposed to be 68. What did it come out to be right here? The .9772. What did it come out to be? I thought y'all were hollering out the decimal a while ago. That's why I was wondering. 68 minus 50. What does the area come out to be? From negative infinity to 68.
Got 2.57.
2.5, but that's not.
That's all I say.
What's the area?
That's why I gotta do it.
Not aggravated at y'all, I'm aggravated at. That's why I don't hit yes. For those of you that always say hit yes.
0.9949.
Just forget it now. I've already got it. It's already erased, so. Thanks to this T-Rex setup. For those of you that don't know, I teach in AC 137, which is the Polycom room, which is set up for 2019, not 1966. And it's kind of aggravating to go from a room that's set up for technology to this, and it's very frustrating. Sorry, I'll shut up. So C and check, and it should ask you for another. You got to hit continue. All right, somebody give me that. What was it? 0.38 what? 0.3825?
Yes.
Okay, so that's a test question. Let's find another one. All right, try that one. Same scenario, 50 and 7. Find the 81st what? Percentile. Find the 81st percentile. Or how do you say 81st percentile? 81%, which means 0.81 what? 00. Now this one you're going bass backwards. We haven't done one like this, so everybody should be writing this one down because you haven't done one like this before. So draw a picture, and this time you need to draw 81%.
Yes.
What's these other two? 36
Yeah, 36.
and 29. Thank you. I'm terrible with subtraction. So let's go. We know that this is 50%, right? And what's 50 plus 34? 84%. So we know that 81 is somewhere what? Right in there? And you're drawing 0.8100. So what are you given? Are you given a z-score and you find the area? Or if you're given an area and you find the z-score? That's not rhetorical. I'm asking y'all to interact. What are you given? Articulate. So I'm going to ask again.
You're given
a what?
an
You're
area.
given an area. So therefore, you've got to find the what?
Z-score.
So that means you got to use inverse norm. So somebody type in 0.8100 on inverse norm and tell me what you get. We know it's going to be above 0.5, don't we? So what is that z-score?
I got 0.88.
Okay, somebody second that, because I'm not doing it on the board, so it's just too much trouble. So somebody check inverse norm, 0.88.
Oh, that's
Okay, now you've got a z-score. What the hell do you do with it? Because 0.88 on a scale of, if you're doing IQ scores, and IQ scores range from a mean of 100 to a standard deviation of 50 to 150, what's 0.88 mean? Not too much. So if this is, I don't know what this could be. If this was average points of a basketball game, I don't know, whatever it could be. 0.88 means absolutely what? Nothing. So what formula are you going to use to change this into an x? Oz plus mu. And you need to write it down because I haven't shown you this before. X is equal to Oz plus mu. I don't know why I wrote it offset like that. Basically, if you take the I can't talk this morning. If you take the z-score formula and you solve it for x, that's what you get. Hubert, why don't you use the x bar and the s? Because try to remember that with s bar and s. With x bar and s, it doesn't make any sense. Why am I using the sigma? Because it looks like Oz. And what do we all think of with Oz? Wizard of Oz. And then mu is a whole lot easier than dealing with S. So that's why I use Oz plus mu. Now, plug and chug. Plug and chug. What is your standard deviation? What is your z-score?
0.8.
And what is mu?
50.
Plug and chug. What'd you get?
56.16.
56.16. Is that feasible?
Yeah.
Why?
Because
Because your first standard deviation is 50 what? 7, and you said it was going to be right before you get to 57. So it's feasible. And that's why the empirical rule and drawing a picture is so important. Now, who does this affect? Well, the people that are LADs and the people that know everything, they won't draw the picture. Everybody with me? And the question may be worded, and if they don't draw the picture, they just throw in whatever the calculator gives them, and they get the question wrong, and who they get mad at? Me. Yeah. So that's your answer. Your answer should be, what does it say, round 2? Round 2. 2. Of course, this is, so let me move this out of the way. At least that works. So 56.16. Is this math very hard? Is it very difficult? No. You just have to know the methodology to do it. 56.16. And you feel good about yourself. All right, look at this one. Now, y'all know this is the last section, right? So what does that mean? That when y'all come back Thursday, test. And this is your Unit 3 test. All right, so the mean incubation time for a fertilized egg kept at a certain temperature is 23 days. Suppose the incubation times are approximately normally distributed with a standard deviation of 1. Complete parts A through E. So what's the first thing you're going to do? Draw what? Draw a picture. You're going to draw a picture no matter if you want to or not, because on this one, you're going to have to. I know, I'm a bastard.
A lot of these have like 8 parts to them.
I know, and I don't like doing these, but for this type question, for what it's trying to get across to you, it's a good thing. Because this is 100% empirical rule. It should be, because you don't have any other way. Okay, the mean incubation time temperature is 23, so you might have a Z-type question, but so I want to draw a picture. And I'm going to draw a very good picture because I think this is kind of targeted to the empirical rule, but I may be wrong. So that's going to be 23. So this is going to be what? 24, 25, 26, 22, 21, 20. Now y'all may remember me warning you about a question like this. What is the probability that you're going to have one within 1 day? 68%. When I say within 1 day, what do most people think? They think 24 days. They don't think what? 22. You got to be careful with that. And remember, the whole point of going over a lot of these questions is because people can do the math. What do they not do to the question? They don't read it. Because they either know everything or they try to, do it so fast. So, let's go ahead and fill this out. 0.15, 2.35, 13.5, 34, 34, 13.5, 2.35, and 0.15. Another reason I know you haven't done your homework is you're not sick of drawing pictures yet.
Oh,
If you've done your homework, you're pretty sick of it. Unless you did what I told you and copy those pages off. Which 1 or 2 of you will do, the others don't. So now you've got the picture that pretty much you can do no matter what. Unless they ask you to do a Z-score, and then you'll have to calculate the Z-score. So I don't know which one this one is. You got to look at each one. You got to look at each one. I don't know. Okay, 26. That's not right because it's 23. 23, that looks right. So that might be it. 23, nope. So B is your answer. Next. Find and interpret randomly selected hatch less than 22 days. Now we're going to do it 2 ways because it says 4 decimal places. You could do it by the empirical rule or you could do it by Z-scores. We're going to do both because I have no idea. Since it is in the Z-score section, 7.2, I'm going to do the Z-score. So we'll do the approximate in blue. So somebody add up 13.5 and 2.5. Same old 16. So by empirical rule, I'm going to do 0.1600. And I'm going to put an approximate there so you know that we did it by the empirical rule. Now I'm going to take another color, which I don't like red, so that means I'm going to use magenta. And I'm going to change 22 into a what? Z-score, Hubert. That's right, class. 22 minus 23 over 1, which is going to be what? -1. So in your calculator, I need you to give me the area between, what's this area called? Negative infinity to what? -1. Now, if you have your calculator, you can type in 23 and 1, and you don't have to change it into a z-score. Again, that's why you have to know this stuff. Of course, some of y'all created the calculator, so just like my mother-in-law, she invented the first computer. So, somebody tell me which.
I mean, that's right now. I mean, that's right.
Well, is it 16%?
Yeah. 0.16.
Well, that's why you do that.
0.1586.
So, by the z-score, we have a, what's the word? Exact. This is approximate. This is exact. Exact is usually done with radicals, but since you don't have radicals here, we just write the decimal. What'd you get? Point what?
1587.
Now, since this is in 7.2, and what are we studying? Area under a curve, and we're using the calculator, I'm going to go with the 0.1587, because empirical rule is in unit 1. So, 0.1587. And that's how you do this question. Now, the reason I like this question, not for a test, but I like it for homework, because if you can do this question, you can pretty much handle any question I give you on the test. So, 0.1587. Watch me get it wrong. Just want the 16. Nope. Next. All right, try that one. This one says, let me erase it. Okay. Where's the question? Okay, interpret the probability, select the correct choice below, and fill in. Oh, I hate when they ask this. All right, so if 100 fertilized eggs were randomly selected, and you've got a 0.158, so that means 16 eggs are going to be whatever, right? Now, the wording here, we said less than, okay?
See?
Got to watch the wording here, because it says of 100 eggs, exactly. What's wrong with that word exactly?
It could be a different number.
You're not going to use exactly in statistics. So automatically, when you see the word exactly, you just mark through it, because that can't be it. Okay? Because you would lose your job if you said exactly. Why? Because once in a blue moon is the number going to fall exactly where you what? Say it's going to fall or want it to fall. All right? If 100 eggs were randomly selected, 16 of them would be expected to hatch less than 22 days. In every group of 100 fertilized eggs, 16 eggs would be expected to hatch less than 22 days. Okay, they're playing with words here. So I like B myself, because it says if 100 fertilized eggs were randomly selected. Why am I saying 16?
Because you got that.
Because who in here has heard of a 3/100th of an egg? Okay, so you're not gonna write a decimal. You're gonna write. I'm gonna say 16. Okay. Now, why is there a difference between the two? Because everything in statistics should be based on random what? Selection. Everything. So what does that last one say? In every group. There's no random selection whatsoever. None. So that's why it's not C. Does everybody understand that? Is it splitting hairs? Yes. So if I was to write the question, I would ask A or B. I wouldn't put C in there. All right. Find and interpret the probability that a randomly selected fertilized egg takes what? 24 days to hatch. Over 24 days. So, of course, I had to erase mine. So, go back to your picture, and I'll just do a quick version of it. (23, 24, 25, 26, 22, 21, 20), and they're saying more than 24 days. So 24 is right here. So again, that's going to be 16% by empirical rule. But in this case, 24 minus 23 over 1 is equal to 1. So go from 1 to what this area called. So 9999. Somebody type in whatever you need to type into your calculator. Some of you would type in 23 and 1, and you'll be able to do that. Some of you don't have a newer calculator, would type in 0 and 1 and put 1 to infinity, which is 9999. So somebody give me this area. Probably going to be the same. 0.15 what? 15 what? 86. Whatever. Okay, 16. So again, 16 eggs, randomly selected in a group of 100, it's going to be over what? Is exactly or expected? Expected. And that's what they're going to ask. So 0.1587 or 1586, which one is it? 7. Okay. .1587. And it's going to ask you the same thing. So cross out the exactly, which would be B, cross that out.
It won't be A.
And it's going to be C. And you're going to type in 16 eggs. Why? Because you don't have 15.87 eggs. You have 16 eggs. Find and interpret the probability between 21 and 23 eggs. Days, not eggs. 21 and 23 days. So again, if you have a newer calculator, you just have to type in 23, 1, 21 to 23. But if you have an older calculator, you're going to have to change 21 and 23 into a z-score, which would be 0 and negative what? 2? Something like that. So you're looking for this area, which we know this area is going to be 34 and what? 13.5, which is, thank you, what did you say, 47.5? So you know it's going to be 47.5 approximately. So approximately 47.5% or 0.4750. Okay, approximately. So let's find the exact. So somebody with a newer calculator, type in 23, 1, then 21 to 23, and tell me what you get.
0.4772.
4772. So that's 48 eggs. Right? Because you're not going to have 47.72 eggs. And then you go through and answer the questions here. So this is going to be 0.4772. For those of you, when you hit the mouse, it's not supposed to ask this question. If you click this box and click this box, it's going to do it every single time. I've already tried everything. It's not set up right. So 0.57, 0.4772.
You click up.
0.4772. And it's going to ask you, it ain't going to ask you, yeah, it is. So y'all read it. I'm tired of reading it. Which one is it? I'm still trying to get the board to work.
A.
A.
48.
A is 48. See? Okay, which one? A, 48. And you feel good about yourself. The probability of an egg hatching less than 20 days. Well, you don't have to do anything really. Well, you can go ahead and type -9999 to 20. And somebody give me that 4 decimal places. What is it? Wake up. What is it? Shouldn't take that long.
I got 0.0013.
That's good. 0013. Now, what do we know? Now, this is Unit 1. Let's take our handy dandy highlighter. Let's use this green area, this green. What do we know about this area out here? That's your Michael Jordans. Okay, that's your Tiger Woods. Why? Because what? They're outliers. I can't get rid of this. There we go. These out here is outliers, right? So what do you know about outliers? A 6-foot second grader? Okay. Are there going to be another 6-foot second grader in the class? No. So they're very, very usual. So you know that the question right here, now are they going to word it to confuse you? Yes. They're going to word it to confuse you. So what does not unusual mean?
Usual.
Normal. Exactly. You got to watch those. I don't know why they do it. It makes themselves feel big. I don't know. So it's going to be. Let's see what our choices are.
It's going to be would or would not.
Yeah.
So
it would be unusual. Okay. Less than. Remember that there's that 5 cent. Everything is based on 5 cent. When you go into other statistics courses, everything is going to be based on 5 cent. That 0.05. Why? Because that's the highlighted area. 0.05, technically it's right here and right here. That's all unusual. So that should be your answer. Yeah, this is a good homework question because if you can do this question, you can handle anything I give you on the test pretty much. Unless we get that one wrong. Golly, we got it right. We feel good about ourselves. Okay, and that should be, if you can handle that question, you can handle any of them. All right? I'm going to do one more, and then we're going to look at the test. Not look at it. We're going to look at the test Thursday, but I'm going to go ahead and assign it and go ahead and assign the homework because some of y'all are gaffing off the homework again. About 6 of y'all. I don't know what the hell y'all are doing, but anyway, y'all must know it all or just lazy, one of the two. All right, so this is another good question, but I want to try to get one with an even number. Let's see if the next one's even number. Okay, this is good enough, I guess. So do this one. Does it have parts A through E too?
No, it's 3 parts.
A through D.
Okay. All right, I'll get you started on it. I don't know if I'll be able to do this contraption, but anyway. Steel rods are manufactured with a mean of 28 and a standard deviation of 0.07. So think of it as $28 and a standard deviation of 7 cents, so you can add it in your head better. So draw a picture. 28. So we're going to have 2814, 2828, and 42. Somebody check me out there.
Why'd you go about 0.14, Jeff?
Isn't that the,
So it'd be
I did 14 cents.
28,
Sorry.
21. That's what.
So now, that's gonna be 2807. I don't know why, I just did it in my head over, I don't know. 2814, there we go, and 2821. There. And then backwards, 28 minus 7 cents is 27.93. And then 27.93 minus 7 cents is 27.86. And then 27.86 minus 7 cents is 27.79.
Yes.
You put money in your head, you do money in your head a whole lot quicker than you can do regular numbers. Okay? Because what's important to us? Money. That's why you need to use your brain and don't end up on live TV with them dumbasses. All right. So, what does it say? It says, what's proportion has a length less than 27.9? Well, 27.9, that's not close enough. So we got to draw a line at 27.9, which would be right in there. Now we know this is 2.5, so our answer is probably going to be around 2.55 or 2.6 maybe. I'm going to say 2.6 or 0.0260. That's what I say my guess answer is. But y'all need to put in your calculator, you need to go ahead and put 27.9. Okay, somebody type that in and give me the, yes?
Wouldn't it be closer to the 27.93?
Yeah, I'm sorry. I was thinking, let's see, 27.86, so that would be 27.89 right there. So, yeah, I'm sorry, you're right. Be 27.9 there. So, let's see, half of 13 is 7. I'd say probably 6, so 8.5 or 0.0850. Okay.
And that answer is 0.0766.
0.0766?
Yep.
Okay, so that's your answer, and you would type in 0.0766. Okay? And this will say, or longer, 27.8 or longer. 27.8 is going to be,
They're shorter.
okay.
They're shorter than 27.
Okay. Okay, so they're asking you to go shorter than 27.8, which is right in here, and then longer than 28.5, which is going to be up here. So you're going to multiply those two, you're going to add those two together, because they're asking for what? Both. Okay? And we're going to cut it off right there, because some of y'all are acting like y'all are, y'all want to leave, y'all can leave anytime y'all want to. Y'all know that, don't you? I just wanted y'all to know that. All right, let's go to the test. I'll go ahead and look that up. So that way, when y'all come in, we can just do the test and not have to worry about the dates and all. Assignment manager. You already have the test loaded? Not yet. So we'll load the test. Import, next. We're in what?
Be unit 3, I think.
No, I'm not talking about that.
I would.
Spring, we're in fall, what, 19? So spring 19. And test, unit 3 test, 6 and 7, right?
Yeah.
Okay. So now let's go to change dates. Now you're 6, 7, let's see, 6.1, 6.2, 7.1, 7.2, and we'll make that due Thursday. Of course, y'all should just be working on one section. That's the, what, 31st? That's done. And the test, I'll go ahead and work on that. Let me go ahead and pull this up.